This is our last conversation for Chapter 6, and we're talking about as collisions become more complicated. So this is based on the fact that you've looked at momentum and impulse, touched briefly on bouncing. Hopefully you're locking in on this idea of conservation of momentum as it applies to collisions, and all we're going to do now is make the collisions more complicated. Up till now, your colliding objects have been in a straight line, and we're going to take that away. And we're going to start introducing some vectors and look at what happens when our collisions are no longer linear. We can also start looking at the fact of collisions that we change direction or have both objects in motion. Conservation of momentum problems, the setup can be more complicated, but so long as you remember conservation of momentum, the solutions are just algebra. Another example would be the idea of a firecracker exploding. Now this is kind of cool because a way to picture it is that as the firecracker has been launched, it has a total mass and a total velocity. And when it explodes, you've got all these individual masses. And in fact, the momentum is maintained. So if you wanted to do some crazy math, you could figure out the mass of each component and then resolve their directions into different vectors and realize that the momentum is conserved for the firecracker before and after it exploded.